Okay, so next type of matrix is symmetric matrix. So a square matrix A is said to be symmetric matrix if Aij equals to Aji. This Aij is the element of the matrix A, okay, where your I denotes the row number and J denotes the column number. Okay, so Aij, if your Aij is same as Aji, then we say that a matrix is symmetric. Aij equals to Aji means what? A12 is same as A21, or you can say A13 same as A31, then A23 same as A32, right? A11 is same as A11 only, right? We can't interchange the positions of 1 and 1. It is same, nothing but A13 will be same as A31. See, in this example you can see there are two H, there are two G, there are two F. Okay, so where there are two H, what is the position of first H? If you see the H in the first row, so it is present in the first row and it is in the second column, right? So its position is what? A1 2. Okay, so position of H is what? A1 2. A1 2. Then next H, this H, it is present in second row and in the first column, so its position is A2 1. So both are same, right? H means both are equal, so Aij is same as Aji. Okay, same thing you can check for G. See, position of this G is what? It is present in the first row and the third column, so it must be same as what? A31. Let us check. This G is present in the third row and it is present in the first column. Okay, so that's why the definition is a matrix A is symmetric if Aij is same as Aji. Okay, then the other necessary and sufficient condition to check whether the matrix is symmetric is your A should be same as A transpose. Means take the transpose of the matrix, and if both are same, then A is symmetric. Okay, next is skew symmetric matrix. So a square matrix A is said to be skew symmetric if Aij is equals to minus of Aji. Means just there is a change in negative sign. Okay, the sign of the two elements are different. If one is plus, other one will be. Okay, so just we are going to change the sign. See in the example, and the other thing you should keep in mind while checking the skew symmetric matrix is its diagonal elements are 0. Okay, its diagonal elements are always 0. Okay, so its diagonal elements are always 0, and Aij is same as what? Minus of Aji. See, you can see in the first example, the element present in the first row and the second column is -1. Okay, and the corresponding element present in the second row, first column is what? 1. So there is a change in sign. One is plus, other one is minus. You can see in the second example also in B, one is 3, then other one is -3, -5, then you're having 5, 2 and -2. Okay, so Aij is same as what? Minus of Aji. Again, the necessary and sufficient condition for a matrix to be skew symmetric is what? A should be same as minus of A transpose. Okay, next is Hermitian matrix. So in Hermitian matrix, your Aij is same as Aji bar. Bar denotes conjugate. Okay, so if Aij is equals to conjugate of Aji, then your matrix is what? Hermitian matrix. And the another thing is the every diagonal element of Hermitian matrix is real. Okay, now let us check. See, in the first example, here you are having -I, correct? Its conjugate is +I, right? See here the element is 3 plus I, its conjugate is what? 3 minus I. 2I, 2I, so its conjugate is what? -2I, minus I. Okay, so conjugates are present. Then in skew Hermitian it will be what? Same definition, just there will be negative sign. Okay, your Aij will be equal to minus of Aji bar. Understood? Just negative sign. Then next point is operation of a matrix. Like first one is equality of the two matrices. So two matrices are equal if each and every elements are same. Moreover, they are at the same place. That is important. Okay, like we can check here. See, in matrix A, the position of 3 is what? 3 is present in first row and the second column, right? So its position is what? A1 2. Okay, in matrix B, position of 3 is again same. It is present in the first row and the second column. Okay, so each and every elements are same, exactly same. They are at the same place. Then we say the two matrices are equal. Okay, because here the place or the order of that element is important. Okay. Next, addition of matrices. So we can add two matrices We can add the two matrices if and only if their order is same. Yeah. See, for the matrix, I have taken an example. What is the order of first matrix? There are 2 rows and 3 columns, right? So its order is 2 into 3. Same thing, matrix B, its order is 2 into 3. So both are having the same order, so we can add the elements. So while adding the elements, just add the elements which are the same positions, right? Like 4 plus 2, then 2 plus 1, then 3 plus 5. Okay, in the same way. So in the same way, we can carry out the subtraction also. In subtraction also, order must be same of the two matrices. Next is scalar multiplication. Scalar multiplication means what? You are given one matrix A, then if you multiply the matrix by any number, real number, so that real number is nothing but your scalar. Okay, so multiply matrix by a scalar means what? Multiply each and every element of the matrix by that number. Okay, so here in the example you can see I have taken 4 as a scalar and I have multiplied each and every term of the matrix A by 4. Next is multiplication of matrices. Okay, so this is a little bit tricky. So while multiplying the matrices, there are two matrices, okay, A and B. So here it's not necessary that both the matrix should have the same order, okay. Now while multiplying, what you have to do is take the first row. See, there are two matrices A and B. We want to multiply A into B, okay. So while multiplying A into B, always take the rows of the first matrix and columns of the second matrix. And so what you have to do, see, first I am taking the first row of matrix A, that is 1 3, and I am multiplying it with the first column of the matrix B, that is 2 6. Okay, like something like this. First row is what? 1 3 into 2 6. Okay, means what? 1 into 2, then in between you have plus sign, 3 into 6. Okay, so this is something like dot product. You will learn it later. Okay, so first number with the first term, second with the second. Just multiply it and do the addition in between. Okay, so we are taking the first row and the first column. So your entry will be in the first row and the first column, A11 type. Okay, then what I'm doing, again I'm taking the first row and multiplying it with the second column. Now we are taking the first row and we are taking the second column. So what is the position? A12. So it will be here 1 2. Okay, so again first number into first, 1 into 4, then plus 3 into 8. Okay, now there is one more row in the first matrix, so I'll take the second row and again I'll take the first column. So I'm taking 2 1, second row, first column, so its entry will be here 2 1 at a position 2 1. Then I'm taking second row, second column, so 2 2, so its entry will be at the position 2 2. Okay, so again while multiplying 5 into 2, 7 into 6. Understood? So in this way, then 2 plus 18, 4 plus 24, 10 plus 42, 20 plus 56, and so on. So we'll get the multiplication of the matrix. Okay. So while multiplying the matrix, always keep in mind, while taking the first matrix, take the rows of the first matrix and columns of the second matrix. First row into first column, then first row into number of columns. If there are 3 columns, then first row into first column, then first row into second column, then first row into third column. Same thing, second row into first column and so on. Okay. But while writing the entries, pay little bit attention over that. Okay. Next, we'll see the example. So now express the matrix A as a sum of symmetric matrix and skew symmetric matrix. So we want to express the matrix A as a sum of symmetric and skew symmetric. So we know the sufficient and necessary condition for a matrix to be symmetric is what? A must be same as A transpose. So first we'll find the transpose of matrix A. Okay. Then what we are doing? See, here the question is not like that. Okay, check whether your matrix A is symmetric or not symmetric. Okay. So what we want to do is we want to express A as a sum of two matrices where one matrix is symmetric matrix and other one is skew symmetric. So what I have done, first I found the transpose of the matrix. Okay, so just interchanging the rows and the columns. See, first row is written in first column, then second row in the second column, third row into third column. Then I'm going to add the matrices A plus A transpose. So simply addition I have carried out. 0 plus 0 is 0, 5 plus 1. Okay, position wise. First number plus first number, second with second, third with third, this with this. Okay, so on. Then, so after that I've got A plus A transpose. Then I'm finding A minus A transpose. Okay, I've done the subtraction also same way. See, in the same way I've done the subtraction. First number minus first number, second number minus second, and so on. Then what I'm doing, I'm adding matrices 3 and 4. This is your third matrix, this is your fourth matrix. Now I'm adding these two matrices. Okay, while adding you can check your A transpose will get cancelled out. See this part, here you're having plus A transpose minus A transpose, which will get cancelled out. A plus A will be 2A. Okay, then carry out the addition, term wise addition. Okay, okay, simply add the terms. Now you can see here you're having 2A. Okay, here you're having 2A, so A will be equal to what? 1 by 2. This 2 will be divided here and addition of this two terms. So yeah, now the other thing I forgot to tell you, we are not going to add this to matrices. Why? Because we want to write express A as something plus something, where this is symmetric matrix and this is skew symmetric matrix. Okay, so we are not going to add this to matrices. We'll keep it as it is only. So half this plus this. Okay, then multiply both the matrices by half. So multiply each and every term by half. Okay, so half into 0 is 0, half into 6 is 3, half into 1 is half, and so on. Okay, now observe the first matrix. See, in the first matrix what you are observing, 3 3, half half, 3 3, positions are same, sorry, numbers are same. Okay, and what are the positions? This 3 is present at the place 1 2, this 3 is present at the place 2 1, this is present at the place 1 3, this is at the place 3 1, 2 3 3 2. Okay, means what this matrix is? Symmetric matrix. Why? Because Aij is same as Aji. Let us observe the second matrix. In second matrix you can see here you are having 2 minus 2, minus 7 by 2 plus 7 by 2, minus 2 and 2. So it is skew symmetric matrix. So what we got? We got A equals to something plus something, where this is symmetric matrix and this is skew symmetric matrix. Okay, so we have expressed A as a sum of symmetric and skew symmetric matrix. Okay, in the same way I have taken the another example. Okay, and just go through it. First, matrix A is given to you, then find its transpose. Then what we are going to do? We are going to add those two matrices A plus A transpose. Okay, check out the addition term wise. Okay, then next we are subtracting the matrices. 5 minus 5, 7 minus 3. See, here already in between you are having minus, and 3 is also having minus sign. So 7 minus 3. Okay, so we got A minus A transpose. The next step is what? Adding these two matrices 3 and 4. Okay, again A transpose will get cancelled out. We will be left with 2A. Again divide by half. Multiply each term by half. Okay, finally you're getting symmetric matrix. Another one is skew symmetric matrix. Okay, so we'll keep it like this. Okay, we are adding the two matrices 3 and 4. Yes, okay. Okay. Next question is express the matrices as sum of Hermitian and skew Hermitian matrices. Now in the symmetric matrix, what we have observed was Aij was same as Aj. Okay. In Hermitian, what was the condition? Aij was equals to Aj bar when it was conjugate. Okay. So here we are going to find the conjugate of the matrix A. Understood? There the condition was for transpose also, what somewhat like that A must be same as A transpose. So there we were talking about transpose for symmetric and skew symmetric matrix. But for Hermitian, we are talking about the conjugate, and conjugate, if you're talking about conjugate of the term, so we are talking about conjugate matrices. Okay, so here we'll find A bar, that is conjugate of A. Method is exactly same. Okay, method is exactly same. See, the condition for skew Hermitian was what? Yes, it was Aij equals to Aj bar. Correct. So Aij and Aj, this is transpose of each other. Correct. They are opposite. And again you're taking bar. That means you're taking the conjugate also. Means here we are talking about conjugate. Means in short you're talking about transpose of a conjugate matrices. Yes. Aij is same as Aji, means it is a transpose. Then we are taking the conjugate also. So we are talking about the transpose conjugate of a matrix. So here we'll take that only. Okay, we'll find the transpose conjugate of the matrix. So a matrix A is given. So first we'll find the conjugate. Okay, what was the conjugate of the matrix? Just changing the sign of I. Yes. Here it was plus 3i. Here it became minus 3i. Minus 2i becomes plus 2i. Plus 5i becomes minus 5i. Okay. In the same way 3i will become minus 3i plus 2i minus 2i. Okay. So just we are changing the sign of I. That was your conjugate. Then what we have to do? We have to take the transpose of the conjugate matrix. So just interchange the rows and the columns. See here you can observe this was your first row. Now it is in the first column. Okay. Then second row is in the second column. Then third row is in the third column. Okay. So that is the transpose of the matrix. Then again same step. Adding the two matrices 1 and 2. Okay, now while doing the addition of the complex terms, add the real term with real term and imaginary term with imaginary. See here the term is what? 2 plus 3i plus 2 minus 3i. So add 2 plus 2, that is 4, and plus 3i minus 3i will get cancel out. Okay, see here in the same thing 1 plus 2 will be 3, then 2 minus 5 is minus 3i. Okay. So add the real term with real term, imaginary term with imaginary term. So in this way, I have carried out the addition of the two matrices. Okay. In the same way, I carry out the subtraction also. While subtracting also follow the same rule. Subtract the real term with real term, imaginary term with imaginary term. Okay. And while subtracting, keep this in mind, minus and then put the bracket for the second term. This is important because if you don't put minus sign, so your answers will be wrong. Okay. So while subtracting, compulsory put the brackets. Okay. So if I open the brackets, what will get? 2 plus 3i minus 2 plus 3i. So 2 will get cancelled out. 3 plus 3 will be 6i. Okay. So in subtracting also, just subtract the real term with the real term, imaginary term with imaginary term. Okay. So check the matrix what I have written. Okay, so I have got a minus a raised to theta. So again the next step is what? Adding 3 and 4 matrices. Okay, again you can see here this a raised to theta minus a raised to theta will get cancelled out. So you will be left with 2a. So again a will be equal to 1 by 2. Yes. So again divide each and every term by 2 or multiply each and every term by half. Now while dividing here for the complex term, right, for this term, divide each and every term by 2. Means it will be 2 upon 2 plus 2 upon 2i. Okay, divide each and every term by 2. So this will be what, 1 plus I. Understood? So I've written like that only. So I'm dividing each and every term by 2. The answer to this matrix is here, and the answer to this matrix is here. See the simplification. 1 by 2 of 4 is 2. Okay. Then 1 by 2 of 2 plus 2i is 1 plus I. 1 by 2 of 4 plus 3i will be what? 2 plus 3 by 2i, because we can't divide 3 by 2. So it will be 3 by 2i. Okay. So in the same way, second row, third row. Okay. Check the division by half, division by 2. Okay. Now next thing what we are observing here is, here it is 1 plus I, here you are having 1 minus I, that is conjugate. Here you are having 2 plus 3 by 2i, here you are having 2 minus 3 by 2i, again it is a conjugate. 3 by 2 minus 3 by 2i, 3 by 2 plus 3 by 2i, again it is a conjugate. So that means this matrix is what? Hermitian matrix. Okay, where your Aij is same as conjugate of Aj. Same thing in the second matrix. Here you can see 1 minus I. Conjugate of 1 minus I is what? It is 1 plus I, correct? Conjugate is 1 plus I because we are changing the sign of I. But in the skew Hermitian, what is the condition? It should be minus of conjugate. So see, here you are adding that only. Minus 1 minus I. Minus 1 minus I. Okay. So here what is the condition for skew Hermitian? Aij must be equals to minus A J I bar, that is conjugate. Okay, here you are having the same case. See, minus 2 plus 3 by 2i, its conjugate will be what? Minus 2 okay, its conjugate will be what? Minus 2 minus 3i. But if I multiply by minus sign, what you will get? 2 plus 3 by 2i, 3 by 2, sorry. Okay, 2 plus 3 by 2i. Okay, so this is skew Hermitian matrix. So what we got? We have written A as a sum of Hermitian and skew Hermitian matrix. Okay. Next, I have given some examples for practice. Try to solve these examples. If you have any kind of doubt, query, please do ask me. Okay. So I have given two examples to express the sum of the matrix as symmetric and skew symmetric, and other one as Hermitian and skew Hermitian. So try to solve these examples. If you have any kind of doubt, please do ask. Next is inverse of a matrix. Inverse of a matrix means what? If there are two matrices A and B, and if you are having A into B is giving you identity matrix, then we say B is the inverse of A. Okay, if A into B is I is what? Identity matrix. Identity matrix, what is the definition? Yes, diagonal elements are 1, rest all are 0. So if A into B, after multiplying matrix A by B, or if you are getting this, then B is the inverse of matrix A. And we denote inverse of a matrix by A raised to minus 1. Okay. Now there is one method to find the inverse of the matrix. That is, we are going to use the adjoint method to find the inverse of the matrix. So to find the adjoint of a matrix, we need to know some few things. First, we need to know how to find the minors of the element of a determinant. Then we are going to see how to find the cofactor. And then finally we'll see adjoint of a matrix. Okay. Now to find the minors. See, first I have written M1, 1. So in this what you have to do, delete the first row, 1 1, right? First row, first column. Delete the first row and first column and take the determinant of the remaining terms. Okay? Understood? Next is M12. 1 2 means what? Delete the first row and the second column and take the determinant of the remaining term. See A21, A23, A31, A33. Okay? In the same way, I found out A13, minors of A13, then A21. Okay? So A22 means what? You have to delete the second row and second column. See? I am deleting the second row and the second column. So you're left with A11, A31, A13, A33. Let us check. See A11, A13, A31, A33. Okay. So in this way you can find the minors. Okay. So just you have to delete the rows and the numbers. First number denotes the row number, second number denotes the column number. So that row and that column you have to delete and take the determinant of the remaining elements. Okay. So in this way we can find the minors. Next is cofactor of a matrix. So to find the cofactor of each and every element, see A11. So here to find the cofactor you need the minors. See I have taken M11, right? What is the formula to find the cofactor? It is -1 raised to the number of row plus number of column, whatever it is given, into M minor of that corresponding element. Okay. See for A11, -1 is 2, your row is 1, column is also 1. So 1 plus 1, M11. Now -1 is to 1 plus 1 is what? -1 is to 2. And square of negative number is positive. So it is 1. So simply you will be left with M11. 11 means what? Delete the first row, first column. Okay. So that is the determinant. Then next is A12. 12 means what? -1 is to 1 plus 2. So -1 is to 1 plus 2 is what? 3. So negative -1 is to odd number is what? Minus. So you'll get minus M12. 1 2 means what? Did the first row and the second column. So these two elements. So see minus of A21, A31, A23, A33. Okay. So in this way we can find the cofactors. See check the cofactor for A13. It is -1 is to 1 plus 3. 1 plus 3 is what? 4. See always keep in mind negative number 1. Okay, -1 raised to even number. If you are having even number means what? 2, 4, 6 and so on. Okay, if you are having even number, so it's -1 is to that term will be what? Plus only. And if you are having odd number, it will be minus. Okay, so just check here. -1 is to 4 you are going to have, so it is positive. So it will be just same as M13. Then -1 is to 2 plus 1 is 3. So it will be minus. Okay. So and to find the cofactors, first you need to find the minors. Once you get the minors, just there will be change in the sign. Either it will be plus or it will be minus. Okay. So in this way I found out all the cofactors. Okay. Next comes the adjoint of the matrix. Now to find the adjoint of a matrix, first we need to find the cofactor of the matrix. Second, take the transpose of the cofactor of the matrix. That is, interchange the rows with the columns. And then finally, inverse of the matrix is what? A inverse equals to 1 upon determinant of A into adjoint of A. This is a formula to find the inverse of a matrix by using adjoint method. So I have taken one example A. So first find the determinant of the matrix A. See, first find the determinant. Always whenever the question is to find the inverse of the matrix, see here your formula is what? 1 upon determinant of A. So your determinant of A should be non-zero. If it is non-zero, then and then only your inverse exists. Okay. So first find the determinant of the matrix. Now let us check how to find the determinant of the matrix 3 by 3. So determinant of A equals to, take with this 1. Okay. So corresponding row and column you delete. Take the determinant of this 1 into determinant of this terms. Okay. Then next, here, while taking the second term, compulsorily you have to take the minus sign. Okay, now minus, what is the second term here? 2, so minus 2. Now I'm taking the second, right? So second column, first row will be deleted, so minus 1 0 0 1. Okay, then last one is what? Minus 2, so I'll delete the third column, so minus 1 3 0 minus 2. Understood? Then find the determinant. So 3 into 1 is 3, minus 0 into 2 minus 2. Then minus 2 into minus 1 into 1, then minus 0. Minus 2 into minus 1 into minus 2 minus 0. Okay, so in this way we find the determinant of the matrix. Now determinant is non-zero, so that's why A inverse exists. Now to find A inverse, we know we need to find the adjoint of a matrix, but before that we need to find minors, then cofactors, then adjoint. Okay, so let us start with the minors of element. So M11. M11 means what? Delete the first row, first column. Okay, M11 means what? Delete the first row, first column. So take the determinant of this part. 3 minus 2 0 1. See, 3 minus 2 0 1. So determinant 3 into 1 is 3 minus 0. Okay, then M12. Delete the first row and the second column. Same thing, M13, M21. Okay, all the elements. See, after M through 2 3 I have now taken M24. Okay, so there are just 3 rows and 3 columns. So M23, third column is enough. Okay, no need to take up to 24. This will ask me the question why we have not taken M24 or M25. Okay, so there are just 3 columns and there are 3 rows only. Okay, so in this way I have found all the minors. Then cofactor C11, just we have to change the sign. M11 we have already found out it is 3. See, M11 is 3, minus 1 square is plus 1, so into 3 is 3. Even number will be plus, odd number will be minus. Okay, check the cofactors. Okay, same thing, C22, everything, each and every term I found out. Then cofactor of the matrix. So while writing the cofactors, write it very properly. Like first number will denote the row number and second will denote the column number. So see, all the elements in the first row start with C1, C1, C1. Then columns C11, C12. Okay. Second row, see first elements are all 2. Third row, all elements are 3. You can check column wise also. See, your second term is always 1 for the first column. Here it is 2 for the second and for 3 for the third column. Okay. So don't make any mistake while writing this. Then what is adjoint of a matrix? It is nothing but a transpose. So just interchange the row with the column. See, first row I have written in the first column. Second row, second column. Third row, third column. Okay. So this is the adjoint of the matrix. Then what is A inverse? A inverse is nothing but 1 upon determinant of A into adjoint of A. So a determinant was 1. So simply your answer is this much only. Okay. So again I've given one matrix for practice. So try to try to find the inverse of this matrix by using adjoint method. Okay. Next point we'll see in the next video. Thank you.